kinematic equations. So kinematic equations is a set of, or are a set, make a set of 5 equations, or this is actually the the plural version or the plural word of formulae, which is formulae. So formula becomes formulae, not formulas. We're just gonna keep calling it equations for short, of course. That can be used. Now, here's the thing about these kinematic equations: they only can be used when you have a situation that involves only what? Uniform acceleration. Your acceleration or the object's acceleration has got to be uniform. Does anyone remember the definition of uniform acceleration? Because remember, there were two kinds of motion we're interested in this course. Uniform motion, which is just what? Same speed, same what? Same direction, which is basically what? Another version of cruise what? Cruise, cruise control. You just keep the same speed, same direction. How about uniform acceleration? You still keep the same what? Direction, but what could you be doing? Again? So, but what's so special about the different speed? You have to be gaining or losing speed at the same what? At the same rate. Exactly. So the same rate of gaining speed or the same rate of losing speed. Okay. Um, so sometimes they are referred to as the big five. That's usually a university term because they are what all is needed to analyze absolutely any uniform acceleration problem. If an object undergoes non-uniform acceleration, so for example, if you're speeding up in a way you're accelerating your acceleration, or you're decelerating your deceleration, such as when you slowly but continuously press on the gas on the highway. You're not just speeding up, you're speeding up at an increasing rate. Okay, so that's not uniform acceleration. If you do that, you are accelerating your acceleration, and we can't do it because the only thing that actually will work for these kind of problems is calculus. So actually, in first year physics, you will do equations. Sorry, you will do problems which you can use the kinematic equations for, and you will also do problems where you can't use them, and they can only be done using calculus. In fact, Mr. Shivers, probably in maybe a month or so, will actually do with you kinematic problems. They will actually be motion problems involving calculus. Okay, he will be using the exact same terminology I'm using. He's gonna be using displacement. He's gonna be using distance. He's gonna be using velocity. He's gonna be using speed. He's gonna be using acceleration. It's exactly the same thing. Okay, because remember something from I mentioned in grade 11. Calculus was invented by two people. One of them was a physics professor, and one of them was a math professor. The physics was Newton from England, and the math was Leibniz from Germany. Newton invented calculus just to analyze what? Displacement, distance, velocity, speed, and acceleration. Okay, so he actually invented it not as a field itself, just as a tool to analyze what? Motion and gravity. Okay? All right. So, what are the equations? Equation number one. Did we actually do that equation before? What this equation that defines what? Exactly, average acceleration. Even though it's already taken, we already covered it, it is considered to be one of the kinematic equations. It's actually considered to be the very first one. Okay. Equation number two. Right? Equation number two. Delta D equals 1/2 VI plus VF times delta T, all in a bracket. By the way, even in first year physics, you will never be actually asked to memorize these equations. I memorize them just because of my continuous practice and experience and using of them. However, it's more important to actually understand why they're like that and how to use them algebraically than to actually memorize them. Obviously, another reason what not to memorize them is coming up. Equation number three, this. Equation number four, this. Can someone tell me how similar those two equations are? Equation number three and equation number four. Are they very similar? Yes. How are they different? There are two who can spot the two differences. Two differences. Ammar, give me one difference between them. They're only different in two instances. Give me just one of those instances. Exactly. This one has VI. This one has what? The opposite twin, which is VF. What's the other difference, Ali? Exactly. One of them has a what? Has a positive or a plus. One of them has a what? Imagine if I asked you to memorize these. Guess how many people are going to mistake in these two or confuse them or completely? Okay. How many mistakes can you do when you actually say this equation if you had to memorize it? Number one, instead of VI here, you could put what? and vice versa. Instead of plus, you could, what else could you forget? You might forget the what? Exactly. So many things could go wrong. No, here's the toolbox. Just show me you can use it. Okay? Equation number 5 is VF squared equals VI squared equals 2AV delta D. Do you notice a difference in the fifth equation that is actually something is not there, but it's in the first four? Just look at the fifth equation and look at the first four. Ahmed? Okay, other than that. Nope, it has distance. Yes. Yes. All of these ones involve what? Which means they involve what? Vectors and direction. This one is what? And the only reason is, look what's happening to the vector. They're being what? When you score a vector, you cannot have a what? Again, Mr. Shivers will teach you that in what? In the vectors unit. When you square a vector or when you multiply a vector by its own self, it is no more a what? It is no more a vector. It just becomes a what? A scalar. Exactly. Okay. So let's actually look at each equation of those. Okay. You will notice that each equation has how many variables? Only 4. Even though the total number of variables is what? Is what? And why do you think we have 5 equations? Because we need what? Sorry, because we have how many variables? But each equation only has how many of them? 4. This is super important, okay? By the way, sometimes when you see, usually when I ask people count the number of variables in an equation, when they see a variable repeated more than once, they count it how many times? How many times? No, you only count the variable how many times? Even if it's repeated 100 times. So for example, let's say someone says this, y equals x plus x squared. How many variables are in this equation? 1, 2, or 3? 2. What's the first variable? Y. What's the second variable? Does it matter that the x is repeated so many times? No, it's repeated in a different way, but whatever you plug in for the x here is the same as what you plug in for the x here. That's the proof. It is the same variable. It's just repeated as many times as you need. Okay? All right. So let's actually look at each one of them. Okay. Which one of those 5 variable is missing from here? Missing. Ahmed? Distance. Okay? So that means, go ahead, put an X on the distance, and that means you put what in the other 4 boxes? Check mark. So 4 check marks for the things that exist in the equation, and 1 that doesn't exist. How about the second one? What's missing from it? By the way, the reason I'm actually asking you what's missing, it's always easier, especially when you actually start to, like use the toolbox of the kinematic equation. It's always easier to see which one you can't use versus the 4 you can use. Okay? So what is missing from the second equation? Say again? Exactly. I have distance or displacement, depending if you talk about scalars or vectors. I have initial, I have final, I have time. The only one I don't have is exactly average acceleration. Perfect. So it's an X on the first one and 4 check marks. Okay, next. What's it missing? Yes, Janan. Exactly. It's got everything with the VI. So the only difference is, or the only missing thing is that it doesn't have the VF. So the VF would be the third X, and the 2 here and the 2 here are check marks. Okay, how about the other one? Instead of missing the VF, you're missing now what? The VI. That's why those 2 are basically complete opposite of each other, algebra-wise. So that means it's the second X. Yep, and 5 and 4. Sorry. Which one is missing from the fifth and last equation? Time. The only one that has no time is the fifth equation, which happens to be also the only scalar looking equation without arrows. Okay? All right? Okay, so now we have kind of like about an attack plan to understand which ones are usable and which ones are not, depending on the situation. Okay? By the way, all of them are super important because it depends what question you're given. However, as you know from grade 11 sometimes, you know that some of them tend to be more used and more common in problems than others. Okay? We'll see which ones are more common. But that doesn't mean that you shouldn't know how to solve any of them algebraically. Okay, so let's go to the next slide. Okay, so The most important thing in any math or physics problem is having a what? Having a procedure, having a strategy, having an algorithm, or basically a list of steps to always make sure that you're going about this very systematically. So when a kinematic problem is presented, let's follow these steps to systematically solve it. Step number one, if needed or explicitly what asked for, you have to provide, sorry, you need to provide a what? A sketch, okay? Sometimes you don't need to. Sometimes the problem is so easy you can just look and you can't imagine it in your head. And sometimes I might just ask you for a sketch. How simple should the sketch be? Stick figure simple. Just the basics. Please don't go crazy with a huge painting. Just the basic as you always see me sketch sometimes. Okay? Step number two. Sorry, step number two. Very important. Decide which direction should be what? Should be positive. Now, from now on, and trust me on this, always choose the direction of what? Of motion to be always what? Even if the motion is what? Even if the motion is what? Slowing down. Yes, even if it's slowing down, it's still going what? It's still going forward. So always make sure that wherever the object is moving, make it what direction? What's the benefit of that? You eliminate the use of what? Vectors. No need for vectors. And by the way, this is the way they want you to do it in first year physics. They want you to be what? Liberated from vectors and just everything be what? Positive or. And then you interpret it as what? As vectors. But always think positive or negative first. Okay? So that eliminates the need of vectors. Also, you can treat everything as either going with the motion or what? Or against it, which basically means either positive or negative. Okay? Step number three. This is always again, those are word problems. And this is where sadly so many people don't like word problems for math and physics because people always have problem doing what? Doing what? Represent the key information using the proper symbols. People have trouble translating word problems. I'm going to do so many with you because each one has its own trick to it. Okay? So state your givens. Once you state your givens, you look at the problem and you decide which one of the kinematic symbols that's not given you are looking for. Okay? Number five. Well, once you know what you have and what you need, you can decide which tool of the five toolbox items you need to actually use. Okay, so decide which kinematic equations to be used. I cannot ever tell you which kinematic equation to use. You need to actually decide that based on steps 3 and 4. What do you have and what you're looking for? Step number 6. Well, okay, everyone, listen up. Step number 6 is completely up to you. Some people like to what? Algebraically manipulate, like play with the symbols and then plug in. Some people are not there yet. So what do? Instead, you put the numbers in, and then it just becomes what? A pure numerical math problem. I sometimes will do that. Sometimes I'll show you how to symbolically manipulate it and then plug in, like at the end. It's completely up to you. Although you should know this from now on. If you ask anyone in first year physics or math, they will always tell you they're huge on playing with the what? With the symbols. Sometimes you're actually given a physics or a math problem with no what? With no numbers, which means what? This is completely useless because it does not help you. Okay, they basically test two things. They test your physics understanding and also your algebra understanding. I'll try to train you on that as much as I can. Number 7. Okay, if you luck out, everyone, if you luck out and everything you're given is already on the right side of the equation, you do not need to what? You don't need to use algebra. You just what? Plug and you just use BEDMAS. If the thing you're finding is on the right side, then you need to what? Yeah, you're going to have to move things around, square root, I don't know, do something. But some algebra needs to be what? Manipulated at some point. Okay? That's it. Those are the 7 steps. Obviously, I will never ask you to state the steps as you go along. In fact, subconsciously, you'll be doing them. If you do a problem correctly from beginning to end, that means somehow you've actually covered all of these steps. So you're fine. Okay, so let's actually start with problem. Actually, we don't have this problem. There we go. Okay. Problem 4 on page 19 of the textbook, of the regular textbook, not the university one of Nelson. In a 100-meter sprint or a 100-meter dash, the most famous race on earth, I guess. Um, and a runner starts from what? What does from rest mean? Which, by the way, is the only possible thing for absolutely any object about to move. What does from rest mean? What does it mean as far as the 5 kinematic symbols is concerned? From rest means what? Initial what? Exactly. Initial velocity is how much? 0. Okay, so go ahead and you can write what? Vi above it. Vi equals 0. Don't worry about units. We'll just look at the units at the end. Okay, and what? Of course, can you ever start from 0 and decelerate? No, if you're at 0, there's nothing to lose. So that means you're at the bare minimum. And accelerates. What is this? Is this acceleration? Why not? It comes after the word accelerate. Why is this not the value for acceleration? By the way, you can argue 2 ways that value is not acceleration. What's always one of the easiest ways to argue that something is not something? Yet it doesn't have a what. So even if you're not sure, look at the what. You look at the what. What do you call this? The unit. What's the unit for acceleration for sure? Meters per second squared. Is this meters per second squared? No. So that must be what? What do you only measure using meters per second or kilometers per hour? Velocity, or let's scalarize everything. No. Remember, velocity is the twin of speed. Just like distance is the twin of what? Displacement. Exactly. So what's another reason that this is what? This is speed or velocity. Did it say it accelerates at or accelerates to? Which means what? You went from an initial speed to a what? To a final speed. This came after that. So go ahead, VF. Oops, sorry. I'll go back. VF. All right. VF equals 9.6. What's 4.2 seconds, of course? Time. Delta T. Go ahead. Delta T. On delta T. Okay. Part A. Calculate the what? Okay. Apparently, they gave us a direction. The motion direction is what? West. Okay. Everyone, let's sketch a quick. You have 2 slides for this, so we have enough space. So let's sketch a quick diagram for this. So where is it? Right here. Okay. So here's the ground. Now we're gonna say this is east, which means this is west. Obviously, if they're moving this way, somehow they start somewhere here and they end. Sorry, not end, and they make it to this spot. So obviously here, I always do this to indicate not motion or being stationary. I like to call it like the vibration lines, like nothing is moving. And obviously here I can use some wind effect. Okay, so here the speed is 0. This is usually my 0 meters per second. Speed here is 9.6 meters per second. And I have time. So the time between those 2 snapshots is how much? 4.2 seconds. Okay, so I have VI, I have VF, I have delta time. What's the question asking me for? For part A, acceleration. So what is it not asking me for? Which one of the 5 is not asking me for? Distance or displacement. By the way, let's just keep calling them from now on all the scalar names. Distance, speed, acceleration. So which equation has no distance in it? Because that's the only one we don't care for. Which one? First one, because the first one does have what? It does have VF, it does have VI, it does have delta T, and it does have the thing on what I am looking for. Done. That's it. So VI equals 0 meters per second. VF equals 9.6. If you did not provide the diagram, I would like to see the values written. delta t equals 4.2 seconds. A, by the way, I'm not going to penalize you if you don't say AAV. The only A we care about is not instantaneous, but average. Okay, perfect. So what we're going to do is just plug in the equation. A equals VF minus VI over delta T. Oh, by the way, which direction we're going to choose as positive? Obviously, west, because everything is moving west. So go ahead and put just plus on top of the W and negative on top of the E. All right? Everyone, do you think this needs algebraic manipulation, or can we just plug and play? Yeah, because everything I have, sorry, yes, everything I have is here, here, and here, which means what? No, you just have to do correct bed mass. That's all. Okay, so obviously, all the units are standard and good, so there's no need for any unit conversion. 9.6 minus a 0 over, again, this is my way of writing 0. You can just write a circle, up to you. Okay, what would that be? What's 4.9.6 divided by 4.2? I know it's between 2 and 3 for sure. So what we get is 9.6 divided by 4.2. Okay, what's the sig fix situation in this problem? By the way, do we care that this one has no sig fix to it? No, because that's technically an exact value, like a constant. 2 and 2. So what would the answer be up to 2 sig fix? 2.3. So it took them 2.3, sorry, they were accelerating at 2.3 meters per second squared. What does that mean? Every second of those 4.2 seconds, they were gaining 2.3 meters per second of speed, not of distance, of speed. Done. That's it. That's how, yeah, what's up? Okay, perfect. So obviously, the textbook is still what? Keeping with the notion of what? Like grade 12, and always making sure that if you start with vectors, you also end with what? With vectors. No, please scalarize it from now on. I mean, think about it. You've already given me a diagram. You've already told me what? That west is positive. So if my answer is positive, it must be pointing what? West. That's all. Trust me. This is the way I'm already training you for first year physics. So might as well just do it now. Okay, so just 2.3 meters per second. Awesome. Sorry, meters per second squared. Okay, question B. Calculate the what? The displacement, or not really displacement, the what? The distance. Exactly. We're going to make everything scalar. Now, here's my question to you, everyone. At the beginning of the problem, how many numbers did we know? 3. We know this, we know that, we know that. Now we know how many? We actually know 4 kinematic information about the problem. What does that mean? Technically, you have how many equations you can use? 4. Why? Because 4 of them have what? This distance or displacement, which means you can use any of them, right? What's the bad thing about thinking that way? What's the bad thing about thinking that you actually do know 4 things about the situation now instead of 3? Ammar? We derived one of them, and not only that, even when you did the math, I mean, sometimes you do the math and you get an exact answer, right? Was that one of those situations? No, this is a what value? Rounded approximate, which means what? If you base something on it, it itself will be even more what? More rounded or more approximate. Also, think about this way. Question, everyone. What if you made a mistake here? And then you use that in part B. What does that mean part B is going to be? So always know in kinematic problems, you can always go to the what? You can always go to the what? To the beginning ones and do A and B as if neither one of them depended on the other. Is it making sense? By the way, it's always like that. Everyone, listen up. Every kinematic problems, you always have to be given how many things? How many? Why? Because every equation has how many unknowns? Can you solve an equation of 4 unknowns with, sorry, of 4 variables with 2 things you don't know? You can't. You always have to be given how many? So you always guarantee there are 3 numbers somewhere. The problem with so many people thinking, they look at the problem and they only see how many numbers? How many? Explicitly, they only see, but they did not translate it properly that from rest means what? You always have 3. Just look deeper for them. Awesome. Okay, so Let's say we did B before A. That means this line would be the exact same, but instead of A at the end, what should I have at the end? I should have delta D. Exactly. I should have distance. All right. So, Janan, you're saying you can use what? Okay. Now, why can you use the second equation? Let's see. We have for part B, everyone, VI also equals what? VF is equal to 9.6. Delta time is, but now I need delta D equals question mark. What's missing from the list here? Not what's unknown. What's missing? Acceleration is missing. Which equation does not even care for acceleration? And that's why it doesn't have it. 1, 2, 3, or 4, 5? The second equation. So we're going to use equation number 2, delta D equals 1/2 VI plus VF delta T. Again, are we going to have to solve or just plug in? Yeah, because I have VI, I have VF, I have delta T. All right. So equals 1/2. Good news about VI is just a 0. This is 9.6 times delta T. How would you clean that up? Like, what would you do first? What would you squish together first? You would do the brackets, obviously, especially that one of the parts in the bracket is a 0. Oh, sorry. I do. My bad. Delta T? No, it's what? Sorry, force of habit. 4.2. Okay. So that means 1/2 times 9.6 times 4.2. Okay. And we can just do the triple products right now. So I can do this. 0.5 is 1/2 times 9.6 times 4.2. What would this be to 2 sig fig? 2 sig fig. Is this closer to 20 or 21 first? This is closer to 20. So 20, and what's the unit here? We're doing displacement or distance. Hello. Hey. Absolutely. Go ahead. From where? The booth downstairs? Okay. Awesome. Nope. Simple enough. Thank you. Is this 2 sig figs? Everyone, 20. Is it 2 sig figs? It's what? It's 1. What's the only way we can write it as two sig figs when there's a 0 at the end that we cannot negotiate? We have to use what? Scientific notation, which is 2.0 times 10 to the, you don't have to say 10 to the 1. It's understood, but I'm just going to say it today. 10 to the 1 meter. Done. That's it. The only time you, in my course, by the way, everyone, the only time in my course that you have to use scientific notation, unless the number is very small or very what? Or very big, is when you have a 0 at the end that is kind of like screwing up with your what? With your sig fig. That's it. Any other time, don't use scientific notation. Just give me the number as it. Obviously, rounded properly and to the correct number of sig fig. Okay? All right. So that's part A and part B. Eric, what's part C? Go ahead. Okay, interesting. So everyone, eyes on me. What was the speed at the beginning? At the very beginning? 0. And then what happened to the speed? It gets what? Increased until they hit what speed? 9.6. How long of a time did they take him to actually get to that speed? 4.2 seconds. And how much of a distance did they cover until they got to that speed? It took them 20 meters to speed up to that. What did they do for the rest of the race? They got, they exactly, they what? They cruise controlled it until the what? Until the 100-meter mark. So technically, how much remaining distance did they cruise control for? Exactly. So that's the whole idea now. Now, since the 80 meters is cruise control, do you need to use kinematic equations? You can, because technically, what's your acceleration when you don't when you cruise control? And technically, is 0 a numerical value that is kept fixed? Yeah. So technically, by the way, look at this, everyone. Question for you. What would happen to every equation if the acceleration is what? If the acceleration is okay, forget the first equation. What would happen to this if the acceleration is 0? Everyone, what would happen to this equation if the acceleration is 0? Yeah, what would vanish? What would go away? The whole thing, right? That makes sense, right? What would happen to the next one? Same thing. Are they the same? What would happen to this one? Okay, what's this equation? Or this one? Isn't that the triangle, right, of distance v and t? Boom, right there. So really, and also this one. By the way, what's the only solution to this equation? If two numbers have the exact same squares, they also must be the what? The same exact number, which means what? Vi is equal to what? Isn't that what acceleration is 0 means? What does acceleration 0 means? Your initial speed and your final speed are the what? Are the same. You got it. That's it. So that means what? Whenever you have constant motion, do you need to use the kinematic equation? Can you just use the triangle that we used on Friday or before? Yes. Perfect. All right. So let's go and actually do it. So, oh, sorry, here. So now, new. So I can just do this. D, V, T. All right. Again, everyone, what's the distance they have to go through now until the end of the race? 80 meters. So that means this one is going to be 80. And they're going to cruise control it at what speed? Whatever they got to maintain. So 9.6 meters per second. Great. This is the one I have to find. So delta D, go ahead, equals what? 80 divided by 9.6, which is equal to 80 divided by 9.6, 8.3333. So 8, sorry, 8.3 seconds. But that was not the actual question in part C. Eric, what was the actual question in part C? What is the what? The entire what time of the race, including the what? The cruise controlling time and the what? And the acceleration time. So what do I do with both times? Add them up. It took them 4.2 seconds to speed up and 8.3 seconds to what? To cruise control. So that means delta T total, you can say? Yes. Oh, yeah, go ahead. Oh, but here I can't. That's the only way I can do this one. Oh, okay, everyone. Josh has a point. He said, "You told us not to use things we got from before, which is including this one, right?" I was talking about when you use actual kinematic equation because of the approximation thing and the possibility you might have actually gotten a mistake at the end of it. So 4.2 plus 8.3 equals 4 and 8 is 12, and 2.3 is 2 plus 3 is 5. So does anyone know the world record so far by Usain Bolt for the 100-meter dash? Just to compare to that, it's not super bad, but anyone knows it? 9.58. So they are roughly 3 seconds behind Usain Bolt. 9.58 meters per second. Sorry, second. 9.58 seconds for a 100-meter dash. So far, it's 10. Okay? So that's a very typical what? Kinematic equation problem. Oh, thank you. You're right. My bad. So what would this be to 2 sig figs? Or just what? 13. Remember? Because again, 13 is a good sig fig. There's no 0 at the end to screw up the sig fig. 13. Good eye. By the way, the reason sometimes I forget about sig figs is mainly because I was actually my undergraduate is my undergraduate degree is in applied math and physics. We barely dealt with numbers. Everything was what? Symbolic, 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 symbolic. Engineers, on the other hand, deal with what? Deal with actual numbers. And by the way, that's why this is always physicists and applied mathematicians deal with the symbols. They build the equation, and then it is given to the engineers to what? To test, to fine tune, to tweak, and so on. They need the exact numbers or experimental physics, not theoretical. Okay, awesome. Let's go to the next question. Zoom out. Okay, question number 2. A jet lands on a runway at 110 meters per second forward. What is that? Initial what? By the way, everyone, when you say initial what? Initial speed. So that means what? The moment it touched the runway, what was the speed? 110, going obviously what? Go in which direction? Whatever forward may be. This way, up, down, who cares? Okay. When stopping or while stopping, the jet can what? Okay, everyone, watch this. Can accelerate at 6.2 meters per second squared. Which way? When something accelerates backwards. Is it really accelerating? It's what? It's decelerating, which means this number, 6.2, is it going to be given a positive or a negative sign when we solve? You got it, because it's going against the motion of it once it lands. That's the whole idea. Okay? So, everyone, let's sketch a diagram here under the question. So, here's the ground. So, everyone, I'm going to say that the jet lands here and slows down this way. So, here, I don't have to sketch a jet. What do you just sketch? A box. Yes, everything is a box at the end of the day. So, go ahead. A box. By the way, eventually, is it going to stop? Anything that's decelerating eventually is going to what? Yep. Okay. So go ahead. Oops, sorry. All right. What was the speed here? Speed. 110 meters per second. When something stops, what's the speed? Yeah. When something comes to a stop, no more motion. Zero final speed. So just zero. Is this correct? What did we say? If we're not going to put directions, we have to compensate by pluses or minuses. And this 6.2, is it pushing it forward or pulling it backward? Which means it has to be what? Exactly. If this one is pointing this way, it's positive. Obviously, this never needs a sign. This one has got to be negative. You got it. So let's put this positive here, and let's put negative. Okay. Yep. Perfect. That's all we can put on the diagram. Okay. Part A. Calculate the minimum time it takes to stop. Okay. Let's put the given variables so far. Vi equals 110. Let me do There we go. Vf equals how much? 0. It stops. That's it. Acceleration is equal to what? Uh, that's, by the way, just so you know, everyone, listen up. Pencils down for 30 seconds. Listen up, everyone. The way you know that you used an illogical value for acceleration is that you might get a negative time. What does that mean? Are you going forward in time or backward in time? Can you ever go backward in time? No, time only goes what? Because final time always comes after initial time, not the other way around. So that's how you know, oh, I've forgotten the minus. So minus 6.2. So what are we looking for here? Minimum what? Time. So delta t equals question mark. What is missing from the list? Not unknown, missing. Displacement or distance. For some reason, we're not caring yet about how far it traveled until it stopped. Which equation does not care for distance? First one. Awesome, just like the first question. So A equals, oops, sorry. Let's do it here. Okay, A equals VF VI over. Is this a plug-in in, or do we actually need to arrange? Why? Because is there something missing from the right side? Yes. We don't know this one, but we know everything else. We need to play with this a little bit. Now you can play with it with numbers or with symbols. Let's do it with symbols now. How can you always play with anything? Something equals a fraction. Crisscross, which means you have to show the what? You have to show your best friend, which is the one under the A. Exactly. So go ahead and crisscross. Okay. Now it doesn't really matter what you write on the left side of the equal sign. You can write A delta T, or you can write VF minus VI. It doesn't matter. Since we are looking for what, by the way? Which one of those variables are we looking for? Time. So let's put whatever has time in it on the left side, which obviously would be what? Would be A delta T. So A delta T equals, obviously, VF minus VI times 1, which stays the same. Okay. Can I further rearrange this to solve only for delta T? What should I divide both sides by? Exactly. Or I can just jump to this step. It's completely up to you. You're going to end up doing this either way. Delta T equals this guy minus, sorry, divided by this guy. Perfect. We are now ready to what? Everyone, what's my final velocity or speed? No, final. It stopped. So it became what? Subtract. What's your initial velocity? Okay. Watch out. What's your acceleration? Okay, hold on. Don't copy. Let's play devil's advocate. Let's say you got 6.2, or you use 6.2. What's 0 minus 110? Negative 110. What do you get when you divide a negative by a positive? But time should always be what? Or time progress should always be what? Exactly. That's how you know you missed one small but important thing. You got it. That's it. So what's the final answer? Let's see. Obviously, what's a minus divided by a minus? So you don't have to even show them. You can just 110 divided by 6.2. What's the significant situation? Well, 110 has how many? 2. 6.2 also has 2, and the 0 is exact, so it doesn't contribute. So what would this be to 2 sig fig? It's 17.7, so it rounds it up to 18, and 18 it is. 18 what? What's the unit? Second. So it would take this jet 18 seconds to lose all the speed it landed with. Great. What's question number 2? Sorry, part B. Ammar, listen up. So minimum, what should be the distance that you should actually build the runway to actually to really go over to make sure you get 0 speed by the end and not before? Because if you got it before, it's gonna keep moving, which means it's gonna crash into something. Can I use the 18 seconds? Can I? I can. Should I? I shouldn't, because it's an approximate, and we do not want to rebuild another thing on approximate. Okay, so let's look at the okay, so I have VI, VF, A, but instead of delta T, I need what now? Delta D. So what equation is missing time? Missing time. 5. 5 alive. 5, equation number 5 is the only one that does not need time. Great. So that means B, VI equals 110, VF equals 0, E equals negative 6.2, delta D equals question mark now. Delta D? Yeah, delta D, right. Okay. Can someone tell me which equation again? Which number? 5. Okay. VF squared V initial squared plus 2a delta d. Is this going to be a pure plugging in or a rearrangement? Why? Because apparently something on the right side we are looking for. Okay, you know what? Let's do this one with what? With numbers. What's the final velocity or speed? No, final. 0. It came to a stop. So this will become 0 squared equals initial speed 110 squared plus 2. What? Everyone, listen up. What do you think is going to happen if I did 6.2 instead of negative 6.2? Am I going to get a positive distance or a negative distance? No. If I didn't, I'm supposed to get what? Positive distance because I went forward more. What if I got a negative distance? That means I went what? Backward. Did the plane go backward? Impossible, because it touched at a speed of 110 forward, so it means it has to go what? Forward as well. Good. So negative 6.2 times delta D. Okay. What's the cleaning up procedure here? What should I do first? Can we just get the numbers done? Yeah, exponents, exactly. So obviously, what's 0 times 0? 0. What's 110 squared? Well, I know that 11 squared is 121. And times 10 times 10, that's with the 2 zeros. So 121, 0, 0. Now, what's a plus times a minus? Minus wins all the time. 2 times 6.2 is 12.4. Still times what? My unknown variable. What should I do now? I'm trying to solve. No more physics, just pure grade 10-9 math. What do I do? Yes. By the way, you can do one of two things. Josh, what's your move here? Uh-huh. Sorry, this one or this one? That one. So, so okay, that'll be one way. What's the other way? Ahmed? You can move this one and hit two birds with one stone. Your variable goes to the left side, which is more natural. Also, what? The minus becomes a what? 100% your way, though. Okay, doesn't really matter. So move this guy with both the coefficient and the variable. You can't just use one of them. They're both one unit. So 12.4 delta D, that's the point, equaling 1200. Sorry, 121 with the 2 zeros. What's the annoying number here? 12.4. So delta D is 12100 divided by 12.4. What do we get? Well, 12100 divided by 12.4. Now we are talking about what? 2 sig figs. So let's put this in scientific notation first. So obviously this would be what? 9.76, because this 8 would bump this 5 to a 6. So 9.76 times 10 to the what? 10 to the 2. In what unit? It's a distance. It's a space. So it's in what? It's standardized so far, so it's in meters. Now, how many sig figs do I have here? I need what? I need 2. So that means if I cut it at 2, this 5. Actually, you know what? Um, I think okay. That was actually something that a mistake on my part. You see, I rounded here, which means it could have led me to believe that this 6 might actually what? Round. Do you see what I mean? What if this was staying as 4? Then this should be staying at what? As 7 as well. So let's actually, instead of rounding, let's just put it as is, which is what? Cut it at what? 9.75. Don't round until you what? You get done with the scientific notation. My bad. So 7.5. And now I'm going to round to 2 sig figs. What would this be to 2 sig figs? 9.8. I know it came out to be the same. But what if it didn't? What if I was fooled to actually believe that would have been 9.74? No. Cut, and then you decide. So 9.8 times 10 to the 2 meters. Can I express this one as a regular standard notation? I think so, because it's just what? 980, which is 2 sig figs. By the way, I will never take marks off whether you are more into scientific notation expression final answer or not. I don't really care. It's up to you. Almost a kilometer of what? Almost a full kilometer of safe distance stopping. Okay? What's part C? Anyone? Uh-huh. Explain why. Why should it be much longer? Much longer. Why should we go further than 980? Yep, give me one reason. The jet might have been faster, right? Even, by the way, even 5 meters per second faster, like at 110, 115 meters per second, would actually what? Would drive it maybe like what? A few meters ahead. What's another reason? Uh-huh. Say again? So, so maybe it was not slowing down. Maybe the brakes are not as good, right? So that means what? The slowing down is not at negative 6.2. Maybe it's not. It's negative 5 or negative 4, which means what? You're losing more or less speed. You're not. Yeah, you're not losing as much speed. You're still gonna go what? Further. What's one more thing as well? Landing conditions, right? What if there's ice? What does ice do? Increase friction or lower friction? What does that mean? You're gonna go what? You gotta go. You got. It's gotta go. It's gotta go further because slowing down what at much lower rate. There you go. So just you just have to a lot of factors go in. Okay, and that's basically what the basics of what kinematic equation.